Welcome to another episode of Learning. Please like my videos and share them with your friends and colleagues. Yes, this is my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the question paper IIT JAM Mathematics 2024. In this video, we discuss the solution of a problem from the section Algebra, and the problem is from the section groups, and the question carries a serial number 11. This question is suitable for all these examinations, especially for the aspirants of CSIR NET exam and GATE mathematics exam. Right. So, we first begin with learn a concept and related results. We first learn the concept of the partition of a positive integer n and its relation with a permutation in Sn. After learning this, we go to the question number 11 from group theory. First, we start with what do you mean by partition of a positive integer n? A partition of a positive integer n is a way of writing n as sum of positive integers. Of course, without considering the order. The order is immaterial. Formally, n is equal to n1 plus n2 plus nk, with n1 greater than or equal to n2 greater than or equal to etc. greater than or equal to nk. Each ni is called a part of the partition. We write a partition as n is equal to bracket n1 comma n2 comma etc comma nk, or sometimes we write n1 plus n2 plus etc plus nk. The number of distinct partitions of n is denoted by the partition function p of n. Right? And we first give an example. The partitions of the natural number 4 are 4, 3 plus 1, 2 plus 2, 2 plus 1 plus 1, 1 plus 1 plus 1. These are the partitions of 4. Right. P of 4 is 5. So there are 5 partitions for 4. We give another example. The partitions of the natural number 5 are 5, 4 plus 1, 3 plus 2, 3 plus 1 plus 1, 2 plus 2 plus 1, 2 plus 1 plus 1 plus 1, 2 plus 1 plus 1 plus 1. Right. Lastly, 1 plus 1 plus 1 plus 1 plus 1. 5 ones. So, P of 5 is 6. You can try for 6. P of 6 is 11. And this partition function grows enormously as n increases. Right. Right. So, what is we talk about partitions and permutations. Cycle decomposition, we know this one. Every permutation in Sn can be uniquely written up to ordering of cycles as a product of disjoint cycles. For example, in S6, this is the permutation sigma, right? And we write it as a cycle decomposition. 1 goes to 3, 3 goes to 4, 4 comes back to 1, 1, 3, 4. 6 goes to 5, 5 goes to 6, so this comes back to 6. And 2 is fixed. This is the cycle decomposition. That means this permutation sigma is written as the product of disjoint cycles. Right, we got the cycle decomposition. What is the connection between the partitions of the natural number n and the permutations of Sn? The cycle type, we define a cycle type of a permutation. The cycle type of a permutation corresponds to a partition of n. Right. If sigma belongs to Sn and it decomposes into cycles of lengths L1, L2, Lk, decomposes means written as the product of disjoint cycles of lengths L1, L2, Lk, then L1 plus L2 plus Lk is equal to n, and this is the partition. Thus, each permutation has a cycle type. L1, L2, Lk is a cycle type, which is a partition of n. So, corresponding to each partition, we can write a partition of n. That means every permutation has a cycle type. The cycle type of sigma, the above example, the cycle 1, 3, 4 multiplied by the cycle 6, 6, 5 and 2 is fixed. The cycle type is 3, 2, 1. That is a permutation. That is a partition of n. 3 plus 2 plus 1 is 6. That is a partition of n and it is the cycle type. Right. Now, every permutation, sigma belongs to Sn, corresponds to a unique partition of n known as the cycle type. And every partition of n corresponds to one or more permutations in Sn that share the same cycle type. For a given partition n, there may be more than one partition in Sn that share the same cycle type. Right. We continue in the next slide. Right. The order of a permutation. If a permutation sigma belongs to Sn decomposes into disjoint cycles of lengths L1, L2, Lk, then order of sigma is equal to LCM of L1, L2, etc. Lk. For example, in S5, let sigma be the cycle 1, 2, 3 multiplied by the transposition 4, 5. Then the cycle type is 3, 2, 3 plus 2. The order of sigma is LCM of 3, 2, that is equal to 6. In S7, let sigma be transposition 1, 4 and cycle of length 4, 2, 5, 6, 7. 3 is fixed. The cycle type is 4, 2, 1. We write it in a decreasing order like this. And order of sigma is LCM of 4, 2, 1, that is 4. That is 4. Right. If the cycle type of a permutation sigma belong to Sn is the partition L1, L2, Lk is equal to n, then the order of sigma is the LCM of L1, L2, Lk. So, take a permutation, write the cycle decomposition, from that you will get a cycle type. The cycle type means a partition, then you calculate the order of sigma like this. No, so the order of a permutation is completely determined by its cycle type, that means by its partition. Right. Right, we stop here and we move to the question now. Right. This is our question 11 that has come in the IIT JAM Mathematics Exam 2024. The given example, the given question is, which one of the following groups has elements of order 1, 2, 3, 4, 5, but does not have an element of order greater than or equal to 6? That means we have to find out that group that has elements of orders 1, 2, 3, 4, 5, but does not have an element of order greater than or equal to 6. We are given 4 options. Option A, the alternating group A6. Option B, the alternating group A5. Option C, the symmetric group S6. Option D, the symmetric group S5. Let's now discuss the solution of the problem in detail. We recall the order of a permutation in Sn is the LCM of the lengths of the cycles in its disjoint cycle decomposition. In other words, it's the LCM of the cycle type, that is the LCM of the corresponding partition. Right. Let's first of all take option C, that is S6. Right. What we see is in S6, certainly there is a cycle of order 6. The symmetric group S6 has a 6 cycle, that is sigma is equal to the cycle 1, 2, 3, 4, 5, 6, whose order is 6. Whose order is 6. Thus, S6 has an element of order 6. But we have to look for that example of a group which doesn't have an element of order 6 and greater than or equal to 6. Therefore, S6 does not satisfy the condition. Therefore, option C is not true. We take option D, S5. Now, we can think of a permutation in S5 consisting of a cycle consisting of the product of 2 cycles. The first cycle is 2, the second cycle is 3. And disjoint cycles you can write because 2 plus 3 is 5 is the partition for that. So therefore, the symmetric group S5 has a permutation sigma is equal to the transposition 1, 2 and the cycle of length 3, 3, 4, 5. And it corresponds to cycle type 2, 3, and that is the partition 2, 3, whose order is LCM of 2, 3 is 6. So S5 does not satisfy the condition. Therefore, option D is not true. We move to the next option. Right. Option B, alternating group A5. Now for this, what we do is we give you a table. The table consisting of disjoint cycle decomposition, that is the partition of 5. Partition of 5. Right? The order, the LCM, we will decide it is an even permutation or odd permutation. For this, we take the elements of S5. The elements of S5. From that, we find out the elements of A5. So partitions of 5, I have already written. These are the partitions of 5. 5, 4 plus 1, 3 plus 2, 3 plus 1 plus 1, 2 plus 2 plus 1, 2 plus 1 plus 1 plus 1, and 5 ones. Right? These are the partitions. These partitions can be disjoint cycle decompositions of permutations of S5. And 5, there is a cycle of length 5, the LCM is 5. And cycle of length 5 is the product of 4 transpositions. A cycle of length 5 is an even permutation. In general, a cycle of length, an odd number, length is odd, cycle of length is odd, then it is even. If a cycle of length even, then it is odd permutation. Right. 4 is even, therefore it is an odd permutation, and the LCM is 4. 3 plus 2, LCM is 6, and 3 odd is an even number of transpositions. 2 is even one transposition. So 2 transpositions and 1 transposition, that is odd, and the LCM is 6, odd. 3 plus 1 plus 1. For 3 is odd, is an even permutation, and the LCM is 3. 2, 1. For 2, 1 transposition. For 2, 1 other transposition. The number of transpositions will be 2. Therefore, it's even. The LCM is 2. Here, it is 2, 1 transposition is the odd, and the LCM is 2. And it is an even order is 1, and it is an even transposition, that is the identity transformation. Right. The even ones are here. These are the elements of A5. Right. So now, what do we see? There is an orders of 1, 2, 3, 5 is there, but the order 4, an element of A5, is not there. Therefore, the orders of elements of A5 are 1, 2, 3, and 5. So, do we have an element of A5 whose order is 4? No. To have an order 4, it should have a cycle decomposition of this type, and whenever a 4 cycle comes, it will be an odd permutation. So, no element of A5 has the order 4. No element of A5 is of order 4. But our question says we have to find out that group which has elements of order 1, 2, 3, 4, 5, but 4 is not there. Therefore, it doesn't satisfy the given condition. Therefore, option B is not true. Right? So, the weakness of the elements of A5 not having an order of order 4, that is exploited in this. Right. We move to the option A. Obviously, option A will be the answer because we have seen 2, 3, 4. That means option B, option C, option D are not true. So, we take option A. This must be the answer. Right. Again, we do the same thing. Disjoint cycle decomposition, partitions of 6, order, LCM, even order, odd order. Now, we talk about the permutations of S6, then from that we extract the even permutations. They will be the elements of A6. The partitions of 6, I have told you 11 partitions will be there. 6, 5 plus 1, 4 plus 2, 4 plus 1 plus 1, 3 plus 3, 3 plus 2 plus 1, 3 plus 1 plus 1 plus 1, 2 plus 2 plus 2, 2 plus 2 plus 1 plus 1, 2 plus 1 plus 1 plus 1 plus 1, and all 6 ones. The first one, the order is a cycle of order 6. Order is 6, and it is a cycle of even length which is an even number. Therefore, it's an odd permutation because it can be written as odd number of transpositions. So, if it is a cycle of length R, then it is the product of r minus 1 transpositions. Right. 5 plus 1. 5 is odd, so it's a product of 4 transpositions. Therefore, it's an even transposition, even permutation, and the LCM is 5. 4 plus 2. For 4, 3. For 2, 1. So it's 3 plus 1, 4 transpositions. Therefore, it's even. The LCM is the LCM of 4 and 2 is 4. Even. 4, it's an odd permutation. LCM is 4. 3 plus 3. 3, 2 transpositions. For 3, 2 transpositions. 2 plus 2, 4. Therefore, it's even. LCM is 3. 3 plus 2 plus 1. For 3, 2. For 2, 1. It's odd. And the LCM is 3, 2, 6. 3. It is a cycle of odd length. Therefore, it's in even permutation. The LCM is 3. This is odd. This is even. This is odd. And this is even. Right. The even ones we have picked up. Let's see whether A6 has this property. That means it has elements of orders 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes. So the possible orders, the orders of elements of A6 are 1, 2, 3, 4, and 5. The first condition is satisfied. Now, is there any element of order 6? Yes, it is there, but it is not an even permutation. So, no element of A6 has order 6 and greater than 6 also. So, no element of A6 has order greater than or equal to 6. So, thus all the properties or all the conditions that are given in the problem are satisfied for A6. Therefore, A6 satisfies all the conditions. Therefore, option A is true. Summarizing all the options, the answer to this question is option A. And that is the detailed discussion of the solution of this problem. It is definitely a good question. And I have done it with the help of the partitions, that is cycle types of that. And I've explained to you what is the partition of a natural number and what is the connection between the partition of a natural number and the permutations of Sn and their orders, etc. And I thought this will be the easiest way to understand this problem. There may be a different approach to get this answer, but somehow I prefer this one. I will also say that this is a very good question. This has the potential of appearing as a question in IIT JAM, in GATE mathematics, in CSIR NET examination. Right. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. It is my earnest request to each one of you. Please join as a member in my channel and support me and my channel. Right. Yes, I am sure I will be meeting all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.